Okay. Can we see okay?
Yeah.
Yep. Now, last time we did the formula x equals minus b plus or minus square root b squared minus 4ac all over 2a. It turns out that this piece is really important, because if you have a root of a positive, you're allowed to have plus or minus. If you have root of 0 with the plus and the minus, you really only have one answer, not two, because root 0 plus or minus 0 is the same thing. And you, for the moment anyways, you can't have a root of a negative. So this piece here, it tells us how many roots we have, and it's called the discriminant. Now you can use the letter D or the letter delta, and the meaning is like this. If the delta is positive, that means the number of roots is 2. If the delta discriminant is 0, then the number of roots is 1. And if the delta is 0, then that means no real roots. If it's less than 0, that means no real roots. Okay? So like I said, the idea is not so difficult, but some of the questions can be. So we better have a look at some examples. So just write that down, that's very important, and then we'll do some examples. Got that? Yeah? I still see people writing. Continue now? Yeah, that looks like. Okay, so. You got that, Nikita? Yeah? Yeah. Okay, let's have a look at our first example. It's how many distinct real roots does, let's say, minus 5x squared plus 7x plus 2 have? How many? I want to know how many roots does this have. So, please note, I'm not asking for the roots. I just want to know how many there are. Okay, b squared, yeah, minus 4ac. Yeah? Yeah? So it works out to be a positive, does it? Oh yeah, clearly, because it's like 89 or something, isn't it?
Yeah.
Which is positive. So therefore, minus 5x squared plus 7x plus 2 has two real distinct roots. Okay, so I mean that if that was in the exam, it would only be 1, maybe 2 marks. It's a short question. But let's have a look at a harder one now. Yeah? Okay. Let's have a look at a harder one now. Let's say something like, let's be a good one. Yeah, let's pick a tricky one. So the idea is the same. How many real distinct roots does the following have? Kx squared plus minus 3k plus 5 x plus 2k minus 8. So how many real distinct roots has this quadratic? Okay, now I'm going to do this, but I just want to see if I want you to try, see if anyone can figure it out, because it is much trickier than the last one. Why is it much trickier? What's the big complication here? The k, yeah. There's kind of like two unknowns. Although you can pretend the k is a constant, you just don't know the k's value.
You still need to open the case.
Perhaps not. I'll let you try for 2 minutes.
We just need a sign for the
It's correct, you just need a sign, but sorry, that sounded very religious for a moment. You just needed a positive or negative sign. So I'll give you 2 minutes to try that, and then I'll do it. For sure?
but it's a little
Unless you can prove it in maths, it doesn't count. Yeah. Let's have a look, okay? Let's see. So, it's the same as the last one. We start off by calculating the discriminant, yeah? In this one, what's the b? What's the b? The whole thing, yeah. The whole 3 minus 3k plus 5 squared minus 4ac. Yeah? Now I really have no choice but to open these brackets. That'll be 9k squared, won't it, minus 30k? Plus 25 minus 8k squared plus 32k.
So it will be just k squared?
Will it just be k squared? Oh yeah, k squared.
Yeah, plus 2x plus 25.
2x. Oh, sorry, minus 2x.
Yeah.
No, plus 2x, plus 2x. 2k plus 25. Now I'm not finished because I still don't know if this is positive or negative.
Oh, yeah.
Yeah. Right? But if I do this, this tells me if the discriminant is equal to this, we know the discriminant must be greater than 0. In fact, we know that the discriminant must be bigger than or equal to 24. So we conclude 2 roots. Therefore, 2 roots. 2 roots. What I like about this question is we've proved it has 2 roots, but we can't find the 2 roots because we don't know the k. But we proved it has the 2 roots. We don't know what they are. So in maths, this is called an existence proof. We prove the existence of something without actually saying, there it is. Also kind of religious. Yeah. Right. Let's have a look at a really tough one now. I know that was pretty hard, yeah? Yes. So, are we happy with the first step, where this you're saying is b squared minus 4ac? Ah, this is like the a. This is the b, and this is the c. Yeah? And then I expanded. And do you remember what this part is called? We did this last week. When you take the quadratic and write it like this. What's it called? Do you remember? Good, complete the square. So if you expand the discriminant and complete the square, you end up with this fella. And are you happy to see that that's a positive? Because this is square and this is 24. They're both positive. So the total is positive. So it means that the discriminant is positive. And if we go back to the start, we said a positive discriminant means 2 roots. So it has 2 roots then. Anything else with this one? Now I know that one was tricky. Was a bit tricky. Yeah. I don't know how many people managed to get to the completed square part. Anyways, anything else on this? No? We look at another one now. It's kind of like this. Again, I'll give you a minute to see if you can do it. Find k so that we'll write on the next line. So that minus 7k plus 2 x squared minus 6x plus 1 has no roots. So I want you to find the k, that makes this quadratic have no roots. Now I'll tell you now, your answer for k will be an inequality, meaning your answer at the end will be something like k is more than or k is less than something. Yeah, see, I'll just give you a minute to see if you can get a handle on it. You think you got it, Nikita, or? Yeah. You think you got it? Maybe. Did you end up with something like k is less than or k is more
Yeah,
than?
of course. Like,
Yeah. Yeah, okay, good. Sounds good then. Anybody else? Yeah? Let's have a look. So this time we start off with the answer. We know it has no roots, so we know that the discriminant should be less than 0. We know this for a fact. B squared minus 4ac should be less than 0. Did I get that right?
yeah.
B squared minus, yeah, that's right, isn't it? 36 plus 28k minus 8,
Why do you
isn't it?
expand it? Why do you open the brackets? It will be easier for us
Huh?
to divide then 36 by 4.
Ah, it doesn't matter, I've gone this way now, I'll continue.
Or
That's expanded okay though, isn't it? 28k is less than 28, minus 28, is it? So k should be less than minus 1.
Yep.
Yeah?
yeah, that's right.
Yeah. Okay. That's okay, isn't it? Now let's see, let's do one more maybe. I want to do, excuse me, you're talking when I'm talking, and I don't think that was English, was it? No, okay. Right, can I scroll down? Yes?
Yeah, yeah.
Yes? Okay, so one more example to do, but this is the trickiest one. And again, I'll give you a minute to try it to see if you can get it, but we've done some hard examples now. So I want to see if you can try this. Prove that the quadratic, that's actually important, the quadratic minus k minus 1 x squared plus 6k plus 6 plus minus k plus 5 can never have one root.
You forgot about x near to the b.
Oh yeah, yeah. There should be, of course, an x here, isn't it?
Yeah.
X squared. Right. This is a tricky one now. I want you to try this one. Prove that it can never have one root. Not possible for this to have one. It's not possible for this to be a quadratic with one root. I'll just put that in. I might explain that here. That is, it can never be a quadratic with one root. Now that's tricky. Give it a try, then I'll show you how it's done. Yeah, it's like that, huh? Well, give it a try. My tip is you should still start off by calculating the discriminant. That's my tip. So still start that way. Oh, do you know what I forgot to do at the very start of this lesson? But I think we know this perhaps from the last lesson we did, the graphs. What does it look like when it has two roots, one root and no root? So this is what it looks like if it has two roots. This is what it looks like when it has one root. And you all know the story then. What's going to happen when it has no roots? Fly. Fly indeed, yeah. Yeah. Okay, anyways, back to this now.
it should have like, it shouldn't have one root.
Yeah, like prove that it's impossible for this to be a quadratic with one root.
Can x be negative?
Of course x can be negative, yeah. X can take any value.
Yeah, what was the discriminant?
Yeah, and?
What was the next steps? I equaled it to 0.
And?
And I got x.
You mean you got a k?
Yeah.
And you got a negative k?
Yeah.
What? Okay. So you're saying it is possible?
Let me check. Probably because there was this mistake.
Anybody think they cracked it?
So, can we use not equal sign?
Yeah. Yeah. But you got to be careful, because what you might be doing is not proving that it can't have one root. You might be trying to find the, like, I think you're doing something similar to Nikita, but the actual answer is similar to this anyway. So yeah, do you think you got it? No. Look, let's have a look. Let's have a look. Oh yeah, now we're thinking that's that might be it. Yeah.
No,
I'd say you have it. I'd say you cracked it. It's to do with that, the linear thing. So let's have a look at the answer here. Look up. So usually the way you can prove something in maths is you start off with a statement and continue, we've discussed this, until you end up with a statement that's obviously true. One nice way to prove that something is impossible is to begin by assuming it's possible and then arrive at something that's ridiculous. Okay? Yeah? So you start off by saying, okay, I think this could be a quadratic with one root. You see what happens, and then you should end up with a ridiculous result. Does anyone know what's the name of this type of proof in maths? Where you assume something is true. Not trial and error, no. Do you know what it's called? Risk. Do we know? I'm sure you've heard of it. It's called proof by contradiction. You know this word, contradiction? So you assume it's true, see what happens, and then the result at the end tells you, oh, I shouldn't have assumed it's true because I ended up with something that's false. You know? Look, let's have a look. So let's assume it does have one root. So that the discriminant could equal 0, right? Let's assume that. And I think maybe a lot of you actually did this, perhaps without writing the word assume. But that's okay. So let's see what happens. So we'll assume that it's, let me be even clear, assume it is a quad with one root, that is the discriminant equals to 0. Let's just see what happens. So what's the discriminant here? It's 6k plus 6 squared minus 4
Minus
a
K
C
minus 1. Yeah.
equals 0. Is that right?
Yeah.
0 is 60.
I'm sorry, where?
B 60.
B?
No,
That's
it's
okay?
not right,
B squared minus, I think this is okay. Yeah? Yeah? Thank you. Okay. B, okay, so we expand the B part. So that's 36k, yeah?
man. Yeah.
Plus 72k plus 36. And then what I'll do, well, maybe somebody kindly has expanded this already. What do we get?
Minus 36k
Yeah.
squared plus 20k
Yeah.
minus 36k plus 20.
Plus 20
Yeah.
equals 0.
Yeah.
Okay. And if we clean that up, I think the k squareds are gone, aren't they?
Yes.
It
So-
will be 56k
Yeah.
plus 56.
Okay, this seems like a lot of people got this.
Two people are talking. Yeah.
Ah, well, that's a lot in the maths class. Right, so k is minus 1. More than one person got this result, so that's a success. That's a success. And you might be thinking, okay, Stephen, so I did it. I found the k where it does have one root, and you told me I shouldn't be able to do this. But at least one person, I think, spotted the problem with this. This is not a valid answer. Because if you put the k equal to minus 1 into this quadratic, it's no longer a quadratic. It becomes a linear. In fact, it's worse than that. It disappears, I think, because you have minus k minus 1 and k is minus 1. This piece here becomes 0. If you put k is minus 1 here, what does this piece become? 0. And if you put in minus 1 here, what does this piece? It becomes, what's that, 14, isn't it? So here's our quadratic. Our quadratic is the number 14. When will the number 14 equal 0? Not anytime soon, I don't think, right? So this result is ridiculous. The result is ridiculous. You can't say k is minus 1 because your quadratic then doesn't become a quadratic and it can never have roots. So you might think, oh, well, Stephen, k equals minus 1 means it has one root because the discriminant is 0. But we've just seen, well, what happens? You get no roots, actually. You get no roots here. So this one was very, very tricky, and I think a lot of people perhaps got to here, and one or two of you perhaps figured out that the problem is that it is no longer quadratic. Now don't worry if you had trouble with this. Oh, leave it, it's only a little moth or something. So, a lot of you don't need to worry because this question is too difficult for the exam. But I just thought it was a good, difficult one for practice we can do in class, okay? But just so you know, I've seen both types in the exam before where they say, how many roots does this have? And you say, how many? Or the other type I've seen is they say, what is the value of k so that this thing has so many roots? So,
like find the roots.
and yeah, like I like one, you know, I'm trying to picture a question. Like one question could be they could give you a quadratic and it could have a k in it.
Yeah.
And part one might be something like, oh, it has no roots, or maybe it's some. Oh, I know. It says something like it has one root, and then that is they ask you to find k. So what do you do to start this one? The discriminant equals 0, and then part two of the question might be using this k, find the roots. So you take this value of k and you put it back in, and then you find the roots of the quadratic. You know, that might be an exam question, and it could be something like, you know, 2 marks, 2 marks, or something like this. Yeah? Okay, let me give you some to try. How are we doing for time? We've got a few minutes to practice for homework. Let's say ABC in each. That should be plenty. 1 ABC, 2 ABC, and 3 ABC. No, not ABC for number 3. Just actually B, C, and E for number 3. So ABC, ABC, BCE. Yeah. Can I close this screen?
Yeah.
Yeah. Let's